My name is Josh Santos, and I'm the co-founder and CEO of Noya. About 10 years ago, I had the pleasure of paying my dues in the MIT Chemical Engineering department. I learned a lot of fundamentals in heat and energy balances, how to create flow diagrams, and how to properly deprive yourself of sleep in order to get that degree. Today, I have the privilege of supporting this team of about 30 people that you see on the slide here to build what we're thinking about as a gigaton scale approach to direct air carbon capture that's all electric, interruptible, and water positive. Now, we've got an incredible team of people that's got skill sets ranging in all walks of professional life. Everything from engineering, R&D, commercial activity, project development, you name it, we got it. And from institutions that are leading in what they do, places like Tesla, NG Impact, Plenty, PNNL, and other amazing research organizations. We're ultimately solving what is the biggest challenge that humanity faces in climate change. If you boil down all types of climate technologies, they sort of fall into one of two key buckets. Bucket one is technologies that are working on preventing new emissions from entering into the atmosphere. That's this whole gray chunk right here. This is everything like solar and wind, which prevents us needing to burn natural gas to create electricity, novel ways of making chemicals in order to prevent new emissions, lots of fun stuff like that. There's a second bucket, though, that's required, and that's the removal of historic emissions, this purple chunk here. This is new. We haven't really needed to do this, and it's pretty wild to have to do it, if you think about it. CO2 in the air is really dilute, 420 parts per million. For us to need to do this is pretty crazy, but for us to need to do this on a billions of ton scale is even crazier, and the speed at which we have to get there, I think, is the part of this that really boggles the mind here. We have to scale this industry by about 50% year on year for the next 25 years for us to meet climate targets as the UN has put forward. That's a really big challenge. How do we do that? Well, it's even harder to think about when you couple on top of that the fact that all of these new emerging technologies like artificial intelligence are threatening to make these goals difficult to reach. Whether it's because of the fact that these centers that are going to be performing all of the data processing for AI are incredibly carbon intensive, or whether it's the fact that they also require tons of water in order to operate the cooling mechanisms that are necessary. Coupling all of these things on top of each other is a really wild thing to have to think about solving. At Noya, we're designing an approach to direct air capture that's designed to meet this very moment that we're in right now. Our approach to direct air capture is all electric, meaning that it runs only using electricity and it can integrate directly alongside existing forms of renewable energy. It's interruptible, meaning we can operate intermittently like solar and wind does, and it's water positive. We produce 5 to 7 cubic meters of water per ton of CO2. And since our future commercial projects are going to be 1 million tons, that's a lot of CO2 and a lot of water that we'll be producing. Now, I'd like to talk about our technology like it's a Brita filter, but for carbon negativity, in that we clean CO2 and water out of the air instead of dirty gunk out of water. It works by moving, moving air into contact with the material that we've developed. That material is reactive with both CO2 and water, and it sits inside of a modular piece of equipment that's like a solar panel for carbon negativity. In that, we can build the same exact design to achieve whatever scale we need to. We input energy in the form of electricity to release gaseous CO2 and water from our material. The water we give to folks that want to use it for whatever they need, and the CO2 we inject underground for permanent removal and storage. Now, we've been able to find some incredible traction with this solution so far. We've got millions of dollars of pre-orders for the carbon removal credits that we'll be producing from some of the organizations you can see on the slide here. Shopify is our biggest customer. We're excited to have their support. And we're also excited to announce today that we are partnering with Johnson Matthey, who we got introduced to through the ILP, actually, thank you for that introduction, who's going to be supporting us in scaling up our carbon capture material to the millions of ton scale per year. Now, we're looking for lots of folks to talk to, but really it boils down into a few key buckets. If you're a corporation that's looking to achieve your climate targets and you want to talk about how carbon removal can help you do that, come find me or my colleague John, who's sitting right here in the middle. If you're looking for ways to source water that is really hard to find, and you think that there's a way that we might be able to help you with the pure atmospherically generated water that we produce at Noya, would love to chat about that. Again, we got a lot and we don't really have any use for it in our own process, so we're looking for partners in that world. And if you're looking to proliferate renewable energy and want a flexible load to deploy alongside your assets. We'd love to talk to you about that as well. Ultimately, the demand for clean electrons in this country is going to continue to outstrip supply, and that's something that we are very perfectly poised to help solve at Noya. So again, we'll be at the booth over there in a little bit. Come find me or my colleague John. John, put your hand up so folks see you. There he is. Hey, John, come find us later. We'd love to talk to you. Thanks, everybody.